Hi, and welcome back to question 6. We're still busy with the November 2012 paper 1 for the Namibian secondary certificate higher level papers. Okay, question 6, we're told that the probability that Rangers win a hockey match at home is 0.6, but it's only 0.1 for a match away. Copy and complete the following tree diagram for 2 consecutive matches, 1 home and 1 away. Okay, so let's copy that. I am going to draw it here. So let me just do it a little bit downwards. Okay, win and not win. This is for home matches. And then for away matches, we've got to win or not win again. Win or not win. And let's actually write that in. I'm going to use black to write that in. So win, not win. Win, not win. And win and not win. Now we're told it's 0.6 for a home game. So this is 0.6. And for an away game, it's 0.1. So let's write this as well. Home and away. Okay, that is copied. Now we need to fill in what else do we know? Okay, so we need to fill the rest in. So any tree, any branching, if you add all of the values here together, it must be 0, it must be 1. So what is the difference between 0.6 and 1? Well, that's 0.4. So these two together must give us 1. Same here, 0.1, so we need 0.9 here. Okay, and again, for an away win, it's 0.1, so this must be 0.9. All right, copied and completed. That's question A done. Now question B says, what is the probability that the Rangers win both matches? So both matches, that must mean they win the first one and they win the second one. So that'll be this value right here. So how do we get this value? Well, we multiply along the branches. So we go 0.6 times 0.1. 0.6 multiplied by 0.1. And we can do that on a calculator. 0.6 times 0.1, oopsie, that gives us 0.06. 0.06. And that'll be our answer here, right? 0.06, because that is for a win and a win. All right. Question C. What color should we use? Let's use this color for question C. What is the probability that Rangers wins at least one of the matches? So that means there must be a win somewhere in here. So this one, yes, that counts because it has at least one of the things is a win. What about this one? Win and not win? Yes, that does count because that has at least one of them being a win. So 0.6 times 0.9. Let's work this out again. So 0.6 times 0.9, that gives us 0.54. Okay, so that's 0.54, and we said that is one that counts. What about this one? Not win, win? That'll also count, right? Because it includes at least one win. So this will be 0.4 times 0.1, and that'll be 0.04, but again, you can just type that in your calculator and get your answer. What about this one? Not win, not win. That will not count because that doesn't include at least one win. All right. So I'm going to do 2 methods of how we can calculate this. So I'm just going to calculate this value here as well, which is 0.4 times 0.9, and that'll be 0.36. Now first, before we continue, one way to check if all these values are right is if you add all of them together, you should again get 1. So let's see. Over here, so we've got 0.06 plus 0.54 plus 0.04 plus 0.36. That gives us 1, so that means we've done everything correct. Okay, so option 1 is how to calculate this is we add up all the things that are correct, that contain at least one win. So that'll be the 0.06, this one, plus the next one, which is 0.54, plus this one, which is 0.04. Right. And if we add all of those together, what do we get? 0.06 plus 0.04 is 0.1. 0.1 plus 0.54 is 0.64. Great. Now option 2, we could say that the probability of winning at least one game is the same as 1 minus the probability of not winning any game. So of not winning. So in this case, we've got 1 minus the probability of not winning at least one game, which is 0.36. And that'll give us, again, 1 minus 0.36 is 0.64. So those are the two methods that you can use to calculate the probability of winning at least one of the matches. Alright, that's it for question 6, and I'll see you again soon for question 7.